Hey everyone, welcome to another session of Your Desk University. We are here to educate and gather the computational designers and software developers in the community. We have a Slack channel on our website. Definitely check that out. We'd love to help you out. Today we're going to be learning about virtual reality. And one of the things I've been learning in preparing this session with our AEC Tech experts is how important optimization and face count is in order to make things beautiful and work well for that type of an environment. Our speaker, Caris, has been doing visual arts for 10 years. To get started, it'd be really helpful right now. You'd pause and smash that like button. It tells other people that we're live, that things are happening, and that you saw something you liked. And that's one of the ways that you can say thank you. Speaker today, Caris. Thank you, Caris, for being with us today. And like I said before, she's a virtual realities expert who's been working in the AEC industry. She comes from Orlando, is that right?
Mhm. That's right.
Where I think there's a lot of things happening in virtual reality. And today you're going to be sharing with us a little bit of optimization beautification.
Anytime I have an opportunity to show what we do in virtual reality, what we do in game engines, it's just a ton of fun for me. It's what I do for fun, so I'm really happy to show it to you. So one of the reasons we've even been looking at this as a solution for the AEC industry is because once you jump into virtual reality, if you ever have before, and if you haven't, I definitely encourage you to, you immediately understand the breadth and depth and width and height of everything. You literally see everything in one-to-one scale, and it just makes sense. Showing your shareholders and your clients what the building's going to look like before it's even built, not on a 2D screen, but actually putting them in there, literally putting them into the matrix and showing them like, hey, this is how it's going to that's how it's going to look. I've heard from a lot of different clients like, this would be really great because sometimes we get done with an entire project and completed, and the client comes back and says, I didn't know the back was going to look like that, and they're unhappy and they want changes, but that takes money and that takes time. So what would it be like if you didn't have to do all that? And that's what virtual reality brings to the table. Really, it just creates a lot of solutions for a lot of people. So but when you actually get down to the nitty gritty, and that's what we want to talk about here, right? If you want to bring that to your firm, if you want to make that a solution for you, how can you optimize and pretty up a virtual reality build, and how can you do that for even a desktop build, right? So, um, so specifically in Unity, and we talked a
That
little
was a
bit about
virtual
this.
reality cat, right? That we heard in the background. I
That
just have to
was
point it out. I
Marlin. I
mean,
wonder if I can get her in my lap so that she
it's
can be
totally
quiet.
fine. Oh, yeah.
But Unity is a solution we're using because in it, a lot of you are going to say like, oh, well, what about Unreal? Now, Unreal is a great solution, but in particular, Unity is more powerful in some ways, and Unreal is more powerful in some ways. But the main thing I want to cover right now is how capable Unity is when it comes to beauty and performance. I think that it is the most capable for creating solutions for the AEC industry. That is an opinion, but here we go. If you caught the talk we did 2 weeks ago or so, I'm going to do a quick overview over some of the concepts that we discussed. And if you want to hear more about that or see some visuals, you can jump over to that video on Your Desk University where we went over some more things in depth. But first of all, this is my name. That's my email. I'm a technical artist. I've been working in virtual reality for about 3 years, but I've been working in real-time software development for about 7 years or so. And so I'm an artist first and foremost. I've picked up programming, and specifically in C#, which is why I like Unity, for like the past, how long have I been doing programming? About 5 years, I would say, off and on, and then more seriously in the past 3 years. So, you know, so I'm technically an artist, but when I develop tools and stuff, I'm programming things, and that's what a technical artist means. So let's do that overview I talked about. You guys might remember, Lisa Marie Timon, we talked about draw calls. And what are draw calls? What are batches? They're the same thing. It depends on who you ask. That is how many things the processor puts together when it renders something all at once, right? So if you are literally putting things in a batch, it's what, like what basket it pulls everything through when it renders it. And if you can put more things in your basket, it makes everything run faster. That's pretty much as easy as that is. So that's that. That is the most important thing, and we'll get into a little bit more about that in just a second. We talked, like Tim had mentioned, about reducing the overall poly count of your geometry. We're going to talk a little bit about Unity optimization, a little bit about optimization in code. So those draw calls, it is, like I said, the most important thing. And just a reminder from the last Your Desk we did, we had an example on there where we had a project that had over a million triangles, and we did not reduce the poly count, but we reduced the batches, and we got the frame rate from an unacceptable level to a very acceptable level. And just so that we're saying it, the frame rate is the most important thing in virtual reality because you have a lot of different people, right? You got seriously a ton of different people who are using this, and it is so important for everybody to have a positive experience the first time. If anybody has a negative experience, such as simulation sickness, where you get a little woozy the first time in your VR because you've got like literal like sea legs, being in an unfamiliar environment, your inner ear doesn't know how to handle it. Even if you're like sensitive to like car sickness or sea sickness, you're going to have a super hard time with it. But there are ways to avoid it, and one of those ways is to keep the frame rate high. So this is the priority. We have to keep it between 60 and 90, and even a little higher. Why not? So the way to do that, we got to prioritize batches for draw calls. The major thing that we do is we combine similar geometry. So that means any geometry that has the same material, we can literally combine them so that they are one object, and then that makes them into one batch rather than thousands, hundreds of thousands, hundreds and hundreds of thousands into one, or a few hundred, depending. Using texture atlases. You guys may have seen in like games or like funny character model stuff, when everything looks the same and it has like everything on one sheet, that is making sure that all the textures can be on one image. So it's just grabbing, and it just knows where to grab on that image to render that thing. Reducing the number of total materials is great. There's a lot of different kinds of concrete in the AEC industry, but typically you can get away with just one. And but you know, it's kind of fun to incorporate different kinds. But for the most part, we've got steel, we've got concrete, we've got different kinds of concrete. You can get a little
because you were
creative.
working both with structural engineers, right? That's
That's
not
right.
quite the same for a lot of architects who are doing maybe a significantly more number of materials. But it is interesting that you talked about combining them into one object.
Yeah.
Even if they're different objects, just because then it
Yes.
renders at one time.
That's right, and it's kind of crazy, and we would get a lot of pushback on that pretty often, and say like, oh, well, why can't I manipulate this object? Why can't I interact and move this object in VR? It's because in order to improve the frame rate, I have to make that one object. So that is why we would have to combine the geometry into one object, and then it's literally the same object. So if you remove one and it's the same object as this guy, they would be moving together. So it's kind of crazy. So UI canvases, that is the object that Unity puts all the user interface objects onto. If you just use one, that's best, one or two. And then in that one canvas, here's the crazy part. So let's say you're being a little messy with your coordinates, and on the Z coordinate plane, you have something just a little bit behind something else. That second thing that's a little behind or a little in front is going to be on a different draw call. So if everything is on the exact same Z coordinate plane, that would be one draw call. So everything on one Z coordinate, everything needs to be lined up properly in order to improve the frame rate. And then, of course, if you have things that are invisible, it's important to disable the invisible objects, specifically for the culling mask on the camera. So culling means like removing things. We talk about occlusion culling and things like that. So in the culling mask on the camera, you can disable when you see invisible, or we don't see invisible objects, making sure they are not being drawn. It's because they can still be drawn while disabled, if that makes sense. So yeah, that's all about batches. If you have any questions, feel free to write them in the chat. and then we can go over that. So Tim had mentioned reducing poly count, and there are two major things that we do. We either have polygonal geometry already, so that's going to be your lines, your faces, your vertices that can be seen in a real-time engine, and then you've got your splines, your non-uniform rational B-splines, your NURBs, and those are going to be your math-based things in your programs like Navisworks and Revit and Rhino and things like that. So the first one, if you already have polygonal geometry, you can use a ZBrush, a 3ds Max, a Blender, a Maya to use their proprietary mesh reducing algorithms. They all have different names. I've listed them here. But in all of those different programs, if you are a 3D artist, you know how to manipulate them. You can manually reduce the poly count, which is what we had to do in the old days, back in my day. So cool stuff like Decimation Master and stuff like that wasn't available in the old days. If you are moving from math-based splines to polygonal geometry, you can use a third-party 3D software like a Strand or Rhino. When you save it as an FBX in Rhino, it has an option to reduce the poly count and things like that. So you can also, let's see, no, that's pretty much it. All right, next. When you're in Unity, we can set our objects to static, we can bake our lights and our emissive shader properties, and I've already done all these things for you guys. You can enable static and dynamic batching, disable your runtime global illumination, or bake your GI, and then size up your light map to 4096 so that it all has one map to read off of, kind of like the texture atlas thing that we were discussing earlier with the UVs of any textures that you have, any objects. You would do the same thing with your light maps, because light maps are very similar to UVs and texture maps in that way. If you guys want to talk more about that, just ask some questions in the chat. Code optimization, real quickly, I'm going to show you guys. You can remove your empty update loops, because your update, it runs every tick, calls every tick, and if you have one that is empty, it's going to still take some processing power, even if it's empty, because I would encourage anybody who's doing this to put any functions that just need to stay active on awake rather than on update, so they're not continuously being called. And then, of course, any get component calls that you have, just remove them and replace them with direct references. So here's the fun part. That was just an overview of the last
beautification, my favorite.
Woo! There we go. So I have a little bit of a bone to pick. I want to make sure that I show you guys the lightweight render pipeline. Some of you might be excited to see the HDRP, and we can do that. I would love to, not this time. So the lightweight render pipeline is what was available in like 2018 and lower, and I want to show how capable that pipeline is. And it is also super performant for things like virtual reality, so that's really great for us. Yeah, so I'm going to do a little demonstration for you guys, and here we go. First thing I want to do is show you this guy. We're going to remove those update loops that I mentioned. So we're just going to get rid of these. It's just as simple as I've got an empty update loop. It is not doing anything. Boop. All right, cool. All right, let's jump back into it. Let's open up Unity. Awesome. All right, so what we have here is a simple structure. Like Tim had mentioned, typically working in structural, we've got a little roof, we've got some steel, we've got some trees and things like that. And we've also got some elements on the interior, because I know some of you guys are architects. So we've got some interior elements as well. We'll zoom around and take a look at those things. Pretty cool looking, not super visually stunning at the current moment. Now, a lot of high detail, so we can see there might be some potential. But let's take a look at what is available in lightweight render pipelines for us to make these things really pop. So let's take a look. So let's right here on this side is the game view. So you're going to see these things update as they're going to look in the game. Actually, let's just do a quick little run through. All right, so looking right and looking left. About the same. All right, cool. Alrighty. There's the kitchen. Now, how cool would it be to view this in virtual reality and show your client, right? Here's the bathroom. Now, I'm also currently looking for a house. Now, this would be super fun for realty to be able to show off a potential buyer, like the home that they could be purchasing. And look at those rafters, huh? I know John would like those. All right. Let me go back over here. Oh, I don't want to go back to start. Anyway. So, the first thing we're going to do, there's a bunch of post-processing effects that we're going to enable. The first one I want to do is just enable the post-processing volume. Now, there's a lot more things available in HDRP that I want to point out that have specifically focused on post-processing, such as the fog and light volume, such as the the motion blur effect that you have in things like Unreal. We also have the bloom and things like that. But I'm just going to show you what's possible with just some reflection probes. Now, reflection probes, and keep in mind, all the lights are already baked here. And what that means is that the lighting has been set in a particular beautiful artistic way, and then they've been baked, which means that they literally have been like fixed onto the texture, so they're no longer rendering through the processor at all. They're just pieces of the texture. They're just there.
That was actually one of the areas I had a question about, if I can just
Yeah.
interrupt you about the lighting, because I face, I don't know, I'm not a net rendering expert by any means, so this is probably a, level 1 question, not a level 10 question. But it seems like obviously in a dark room with poor like artificial lights, and I'm thinking in Revit mostly where I do that,
Yeah.
I'm not getting like the illumination that I want, and sometimes I can add like what's it called, atmospheric illumination. But can you talk a little bit about illumination and how you choose your lights in a scene like this? And then you said
Yeah.
you bake them in, which is really cool because then right, they're not rendering every time while you're running around. But you thought about that ahead of time and you chose where to put your lights. And I'm sure you get models that don't have any lights if you've worked with a structural engineering team.
Yeah, absolutely. So there's a lot of things that in this particular scene I've been able to play with that typically in a like working very quick build we've not been able to accomplish. For instance, we want to make sure that we can always move the light. That means the light's always dynamic, which means we cannot ever bake them. But if we are going to be baking lights, such as in this example, we're going to be using area lights. And those area lights are going to be positioned strategically to make sure that it's, for instance, coming through the windows, that's spilling light onto everything else. And then once we have those things set up, and then maybe have like point lights coming from actual like pendant lights and things inside the room and things like that, we want to be able to utilize like studio lighting where we have a key and we have a fill and we have like a rim, like depending. It's mostly key and fill at this point because you can walk around. Typically when you add like a rim lighting, you know at what point the camera is going to be, and in an interactive piece like this, you're going to be moving around all the time. So you want to be able to use different colors of lights depending on the time of day. So adding a little bit of heat or light depending on the what do you call it? What do you call that? Kelvin unit. That is the
temperature.
The
The color temperature.
Yeah, that one. And then you want to add global illumination. So there's the concept of bounce light, right? So the light will come from a source, and then it will, in a typical light, like one that you're talking about, where there's very dim lighting, and in usual computer lighting, like in Revit, it hits one object and it stops. And something that has been really beneficial for computer lighting has been bounce light and global illumination, things like that. What that means is that things are giving off light to other things, and they're bouncing multiple times before they finally like meet their end, right? So if something is bouncing multiple times, if something actually has like a shadow where it hits something else. Those are elements like global illumination. So different objects actually emit light after they've been hit with light, so it's bouncing off. And then we have ambient occlusion. Ambient occlusion, where if two objects touch, the computer is going to put a little bit of shadow in that area to show that no light is reaching in that spot, and it adds a little bit of depth to it. And then, of course, we have our reflections. So a lot of what allows those things to happen is our reflection probes. I've baked some reflection probes into here. And in regard to light, I also have some external environment lighting through the skybox, which typically I don't in VR, but we're looking at this in the desktop, right?
That's really helpful for me because I do, I'm a photographer at background. And so it's interesting because you're talking about like key lights, right? So like, I've figured out how to do key lights. A lot of us have today dealing with this kind of stuff, or like background lighting and things like that. And it's just interesting to think about it just like a video set or anything else.
It really is. I remember when I was learning, that kind of struck me. I was like, oh, it's literally stage lighting. And then it just got so much more fun after that. Let me show you guys the difference that a reflection probe makes. A reflection probe is just going to, we have light probes and we have reflection probes, and the reflection probes bakes in a particular area where those elements are going to be bouncing and where they're going to be reflecting off of. So if we had like a mirror, or for instance, a shiny surface, something with specular, something with a roughness map, and a roughness map is the opposite of what it sounds like. It makes things shiny. It'll allow it to be shiny because it's taking in the things around it, and then it's applying it to that. So it's saying like, hey, you're going to reflect that object from this point. So without further ado, here's our reflection probes. And we're also going to add some clouds. Why not? So there's our clouds. Add some mood, because we heard the rain already, so we got to add some rain clouds, right? All right, so here we go. I'm going to show off what that looks like. Again, this is just the lightweight render pipeline. Okay. All right, you're into the living room.
And how much is getting pre-rendered versus rendered upon, like,
this is all real time.
Need?
Yeah, the only thing that's been baked is the lighting, and that's it. And most of these objects are static, but everything otherwise is real time.
When you're exporting a model, like let's say from Revit and then into Unity, are you having to completely reassign textures? And then do you take that from like a specific texture library, or does any of that carry over?
So it depends. It really does. A lot of middleware will solve for that problem for you. In my work, we did a lot of custom XML to carry those materials over with a custom solution. And we were able to carry the Revit materials over. Now, the issue was a lot of the Revit materials were very low resolution. And so we had to do kind of like a key value pair situation to say like, okay, well, if you read this string and this, then you're going to have to replace with this universal render pipeline or otherwise material that we've already prepared that is supposed to look like, a certain kind of concrete,
Right.
So how does that work? Because when I remember when a couple months ago, you gave me specific materials to put into our Revit model, right?
Yes.
That was like 4K materials, so they came through really good. So do those materials that we put into Revit where we assigned, the I'm getting the words wrong, but like the reflectance and the bump, what do you call that bump pattern?
Mhm.
did those come through directly from Revit, or did you still have to do some kind of key value pair mapping?
So that it's supposed to come through Revit because Revit now is capable of handling those types of materials, which is super
Mhm.
great. And those materials are called, of course, I'm going to forget right now. Um, PBR textures, procedurally
That's
based
right. I
rendering.
was like, I should know this too.
And those PBR textures are now compatible with Revit, which is super great. So they were actually carried over from Revit, passed into to Unity that way. And I did do a little bit of playing with them afterwards. And then in the end, I actually replaced them because I just didn't like them. But that's my
With
fault.
different ones, not with the
Yeah,
same higher quality ones.
but
That makes
it's
sense.
okay. But yeah, what's really great is that Revit is capable of taking in those PBR textures, because when we were first doing the material pipeline stuff in our custom solution, it was crazy how different the terminology was from Revit to Unity. And what I've noticed is that the industry is becoming more streamlined, and everyone is kind of moving toward these PBR textures and keeping all the terminology very consistent, which is great for matching strength. So even if we were going to continue to do key value pairs in that manner, um, I really like the way that the industry is going, because it's just becoming a lot more simple and streamlined, and that's awesome.
Yeah. I want to
Thank
remind everyone that if you're watching this, post some questions. It doesn't matter how silly or stupid they are. We're here, to answer it. Caris has a lot of experience, and she could probably help you get started if your question is just like, hey, I'm just trying to figure out even where to start with VR. What would be a recommendation? I'm putting her on the spot, but maybe she'll have something like that for you. But this is a
Definitely.
beautiful building. Just kind of running around it. I know I shouldn't say this, but I loved how the textures of the blanket were like
Yes.
it just looks so real.
Yeah, it's important to utilize every channel in your material. Um, what really is great about specifically like ArchViz and things like that. This is ArchViz Pro assets from the Unity Assets Store, and I wanted to make sure that these materials were being shown off properly, right? So these materials, every single channel is being utilized. So we have our albedo, our roughness, our normal map, and normal map is the one that adds that little bit of deformation in what would otherwise be a flat plane, without utilizing any additional vertices. So we've also got a lot of really great highlight and spec on that. Like look at me in a structural environment. I'm looking at the wall, right? Um, like, look at this cool wall. This is white plain walls,
But it
but you see
is.
it.
It's really
Yeah,
cool, right? It has that texture, and that
yeah,
comes. Sorry if you just said it, but that comes from that PBR
yes,
um,
hmm
uh, material. Man,
absolutely.
you get on
And
there
it,
and you forget every word.
I know, it happens every time. But yeah, this is just with the lightweight render pipeline, and I think that if you guys want to see more, the HDRP, we could do that. But the lightweight render pipeline is just as capable as Unreal and other things, and it takes even further with the HDRP. Um, so
There's a
that
couple questions about maybe how you got started in Unity, or maybe somebody who's done some C# coding, how they can get into it. Can you talk through maybe a little bit of a intro for those who are programming savvy but haven't done VR?
Oh yeah. So let me ask for clarity. So you're talking about getting started in this kind of field?
hmm in as far as like maybe because a lot of the people who are watching this are AEC computational
Hmm.
designers, not all of them, but that's kind
Okay.
of the assumption that we make, and we understand that you're not all, but we try to serve a specific group.
Hmm.
And so speaking to people who are maybe computer programming savvy, done some C#, maybe some Python, and want to get their feet wet with Unity or visual or virtual reality.
Okay. So I would definitely recommend just going to the Unity website and going to their Learn tab, and just like if you needed, more clarity, just type Unity Learn, and they have a lot of really great tutorials on how to get started, and they have a very specific architectural visualization learning program. And because a lot of it is geared toward games, right? So we don't necessarily want to teach you guys like, the dot product, and we don't want to get you into like platforms and, the Mario style jump or anything like that. So you just in the simple like, character controllers and utilizing the standard assets package and knowing how to utilize the Unity asset store and things like that, you can get up and running very quickly. And I definitely encourage you guys to try. And as far as like C# coding is concerned, it's pretty simple. Just nothing to it but to do it, right?
Yeah, you just got to get started and try
That's
something
right.
sometimes.
That's right. When I first got started, I downloaded an app called Mimo, and MIMO, and I used that instead of like my idle mobile game. If I was ever waiting in line or something and I wanted to pull up like a an idle game, I would just there's a jump. I would just intentionally choose to open Mimo instead, and they had a lot of different like gamified code prompts that also had like a leaderboard and stuff like that, and I was able to like compete against other people, and that was super fun for me. I am super competitive. In fact, just when I'm done with this, I'm going to go play some StarCraft 2, and I'm super excited about that.
Yeah, we're giving up gaming time to be here talking about gaming. Someone has a question here about like, we know Unity, we know C#, and we understand the render pipeline. How can you help us understand more about like architectural specific training materials? You talked about Unity, and that might be your best answer. Are there any other architectural specific things? That you can.
Unreal does a really great job with architectural visualization as well, and they also have a similar like get started package. So if you wanted to try that out, but as far as like bringing architectural stuff into Unity or Unreal, with Unity, I would highly recommend Unity Reflect, and with Unreal, I would recommend the Datasmith pipeline. Whichever one is your flavor, try them both out. But if you're a C# person, definitely Unity. If you're a C++ person, I would recommend Unreal, of course. That is the biggest difference between the two. And if you're more of like a visual scripting person, you think I'm going to say like Unreal, but Unity also has a visual scripting solution at this point. So Unity has theirs, and then of course Unreal has Blueprint. If you're not familiar with visual scripting, it's similar to Grasshopper, I think was what you guys use. That is a visual scripting tool with like the boxes and the lines.
Grasshopper, Dynamo.
Yeah, those. So you guys use those. Unity and Unreal both have visual scripting solutions. So instead of just getting into C# or C++, you can have those solutions as well.
Did you guys hear that? She's not one of us. No, I'm just kidding.
That's true. So true. I remember seeing Blueprint. Sorry, I remember seeing Dynamo and Grasshopper at work and being like, "Oh my gosh, that's so cool!" And then, like when the light bulb went on that you guys use similar programs that as we do in the video gaming industry, I was just like blown away. And we started utilizing that to our benefit and trying to integrate what we do and what you guys do, and that was just super fun trying to streamline that pipeline.
No, that's cool. There are a couple more questions here. Lisa Marie, you want to take one of them while I figure out what the other one is?
Definitely. I think circling back to materials, I know we spoke about it a little bit, bringing Revit materials into Unity. There was another question looking at what options there are to automate that process if you do have to swap out materials. Is that all custom built? Are there resources out there?
So there are a lot of...
And feel free to go into detail what you were doing with key value pair matching if you want.
Oh, okay. So let's see. I'm hesitant to talk about what we did specifically that might be proprietary, but I can mention in general what we did. So basically, if there was a string in Revit that we matched in an XML sheet, and then we said like, hey, if you see this string specifically from this material, apply this material in Unity instead. And then that was just
So you
the
could
same
like
way.
get concrete 1, concrete 2,
Yeah.
concrete 3, and assign them better concrete, or
Yeah.
even just the same concrete.
And I had a material of high resolution PBR textures in Unity that were being swapped out, or if there was no option, it had like a fallback and things like that. And I had a nice, like a gray material. If we didn't have an option, that way I could find it and replace it with something else manually. There's a lot of custom work, but a lot of it was being automated. And the reason why we did the swapping out, and it wasn't for all, but toward the end, we got to a lot of our materials were being swapped out because the Revit materials, sorry, the Revit textures in particular are like this big, itty bitty. So if they just didn't look good. You got close to them like this, oh, well, not like that, like this, and it would just be pixels, you know. So nobody liked that, and we had to come up with a solution at one point in the lightweight render pipeline and later on in the universal render pipeline. And oh yeah.
I was just gonna follow up of like, where in the process does that happen? Does the textures being swapped out happen before it even comes into Unity, or after it's imported into Unity?
After.
Okay.
Yeah, after. And again, that whole process has to happen through an automation process that was proprietary. So again, I don't know how much I can talk about that, but that process in particular, it was like, you know, run this one, then this one, then this one, then this one. And then once it got to the end, that's when the materials were swapped out. And a lot of third-party solutions, for instance, Pixies is Pixyz. And Pixies is a company, and they run a solution for bringing in materials from programs like Revit and others. And they have a material solution that is also using key value pairs and fallbacks. And they also do things with key value pairing, like if they detect a light in Revit, they would replace with a prefab that you've prepared in Unity for that particular instance. And it's very customizable after that. So if that's a solution that you're interested in, you can look at Pixies. In my work, I found that Pixies was unable to handle the size of projects that we typically ran with because, of course, you know, large entertainment projects, skyscrapers, museums, you know, stadiums.
They just couldn't handle the number of triangles and everything coming through.
It was just too heavy, and sometimes it was even just would just crash the program entirely. If you are working on a project where it would be able to use a third-party solution like that rather than a custom automation pipeline like the one that we built, I would encourage you to do that. So it's a ton of fun. I don't know if this is, obviously if you're here, this is your cup of tea. So
oh, totally. And especially if you're at this point in the show, guys, you're heroes. You must really love VR. And AC and Caris, thank you. With that, I think we'll wrap up. Do you have any closing remarks you want to throw in before we do?
Yeah, I just have a little closing slide. I'm going to get you to it. First of all, it's a ton of fun to be here. Thank you guys so much, letting me do what I love to do. So shout out to the ArchViz Pro 6 asset pack available in the Unity Asset Store. You guys can reach out to me if you like on my LinkedIn, which is, there's my name there, my email, and then of course my Instagram. You'll find a bunch of art on there, which, you know, technically I'm an artist. So thank you guys for having me. I really appreciate it.
Well, and with that, we wrap up. Thank you so much, Caris, for your showing us what you've been showing. I'm so grateful to all the people who put this on. And once again, just we ask that you share about things that are going, things you're enjoying, and go to our website, yourdeskuniversity.com, go down to the bottom and join the Slack channel. We'd love to connect with you more. See you guys later.